In this section, we will cover general capacity and sizing information for runtimes. With a focus on performance, here are a few differences between a local atom and a molecule. First of all, don't short sell the atom. The atom is powerful and can handle a heavy workload. The big distinction, though, is that the atom is a single runtime and so may have memory issues when multiple large data loads are processing at the same time. So that's in comparison to the molecule, which is a clustered environment. So as long as there is a defined local working directory, the molecule will be able to process multiple large data loads across multiple nodes. From a fault tolerance view, the atom has minimal downtime during restarts. One caution is that since it's a single runtime, it can get hung up or crash, and that will mean that all processes will stop and not execute until the atom is back up. In contrast, since the molecule is clustered, it can do a rolling restart during restarts, so there is no downtime at all. And if a single node fails, it will not affect other nodes' processes, and then the next execution of that failed process will execute on a different node. Here are a few sizing guidelines. The first thing to know is that performance or capacity is not wholly dependent upon accounts, processes, or number of records. The actual usage and trending may highlight other issues. So that's why it's important to establish a baseline and what acceptable thresholds are for your processes. If an extremely large dataset or a very high transaction volume is required, then you might want to consider having a dedicated runtime for that process. So a very frequently asked question is how many executions can an atom or molecule handle? That's a very difficult question to answer, and it all depends on resources and the processes. But generally speaking, an atom can process 100,000 records per month with increased heap space. Adjusting heap space will improve resource availability. With larger heap space, it's suggested to enable garbage collection to ensure the heap space remains available. And within a node, adjusting hardware resources can increase process capacity as well. Another option in a molecule is to add additional nodes. An additional atom is generally needed when any of the following are evident. When you are dealing with larger data batches, whenever there is a change from batch to real time with high availability requirements, when you have additional process applications, and when you require faster response times from your processes. A molecule is generally used for high availability requirements. Some examples of this might be a web service that has high throughput, or a large batch integration to provide parallel processing and flow control. A molecule might also be a great option for real-time processes. It would probably still be a valuable exercise to load test and monitor the performance of that molecule to justify the molecule. Here are some suggestions for tuning the performance of a local atom. Increase the RAM to up to 1/2 the available physical RAM. For example, setting RAM allocation to 4 GB on an 8 GB machine. Remove or consolidate connector calls. These calls slow down the process execution. Check to make sure the map function ordering is not turned on unless absolutely required. This requires extra processing. Batch query results to reduce metadata storage and writing. Do not run documents individually with flow control unless absolutely necessary. Lastly, avoid selecting all in your queries and extract only what is needed by using filters.